Now let's learn about perpendicular lines. Two lines with slopes, m1 and m2, are perpendicular if and only if the product of those two slopes is -1. That is, their slopes are negative reciprocals. Here are some examples of negative reciprocals. So 1/3 and -3. 5/7 and -7/5. And so are 1 and -1. Those are all negative reciprocals of one another. Show the points P, which is at 3, 3. And by the way, I may have forgotten to put graph paper on yours. Feel free to either use graph paper or just draw a coordinate plane. Show that the points P, which is at 3, 3, so I'm going to graph these as we go along here. Q, which is at 8, 17. 11, 12, 13, 14, 15, 16, 17. Because these points are a little large, I needed to use graph paper as opposed to just coordinate plane. And then 11, 5. So 8, 9, 10, 11, 1, 2, 3, 4, 5. There we go. All right, so now let's connect those. Right, and let me make sure I label them correctly. So P is 3, 3, 8, 17 is Q, and 11, 5 is R. All right, so now there is more than one way that we could determine whether or not these are vertices of a right triangle. But since we're working with slope, let's use slope. All right, so one thing we know about perpendicular lines, so right triangles have a right angle. And what kind of lines meet at right angles? Well, perpendicular lines meet at right angles. So we need to show two sides are perpendicular. All right, so let's find the slope of our three sides. So let's find the slope as a reminder. Slope is the change in y over the change in x, or the difference in the y coordinates over the difference in the x coordinates. So we have PQ would be, I'm going to start with a larger point, 17 minus 3 divided by 8 minus 3. So that would be 14/5. QR, again I'll start with Q, 17 minus 5 over 8 minus 11, so that's going to be positive 12 over negative 3. So that's a negative 4. And then RP, and I'll start with R. That would be 5 minus 3 over 11 minus 3. So 5 minus 3, that's going to be 2 over 8, or 1/4. So notice negative 4 and 1/4 are negative reciprocals from one another. All right, so that means that we have a right angle. They share R, so they have point R. There is a right angle at, so R there is a right angle. So since QR, and I'll put a line, it's a line segment, so we'll use the right notation, is perpendicular to RP. And we know they're perpendicular because they have slopes that are negative reciprocals. angle, we'll use 3 letters, angle PRQ is a right angle. And this is the symbol for therefore. Therefore, triangle PRQ is a right triangle. By the way, the other way we could show this was a right triangle is to use the distance formula, find the lengths of all 3 sides, and then use Pythagorean theorem to show that Pythagorean theorem holds. But since we're learning about perpendicular lines, this seems like a more appropriate proof. I think there's one more activity. All right, find an equation of the line that's perpendicular to the line 4x plus 6y plus 5 equals 0 and passes through the origin. All right, so we don't even have to use point slope for this one because our point is actually the y-intercept 0, 0, 0. So we already know what the y-intercept is. All right, so first of all, let's rewrite the equation into slope-intercept form. So we have 4x plus 6y plus 5 equals 0. All right, we'll subtract 4x and subtract 5 from both sides. That gives us 6y equals negative 4x minus 5. And then we can divide by 6. So y equals, let's reduce that to negative 2/3 x minus 5. Oh wait, we had this before. I knew it looked a little familiar. We did this with the parallel lines. That's all right. You do it a second time. All right, so since the lines are perpendicular, the slope of this line is negative 2/3. The slope of the perpendicular line, we would flip it and make the sign the opposite, 3/2. All right, so let's just write the equation of our line. And in this case, we don't have to use point slope because it's going through the origin. So our equation is y equals 3/2x. And that's it. All right? So in the next video, we're just going to do an application with slope, and that's going to be the end of our look at lines. So thanks for watching. Bye for now.